In this video, I want to show you how to conduct one sample t-test in HAB. So here are the steps involved in conducting one sample t-test in HAB. Step 1. Estimate the descriptive summaries of the variable. This is optional because it's not part of the test, but it's always good to show the descriptive statistics. Step 2. Test for the normality of the variable itself, because one of the assumptions of one sample t-test is that the variable must be normally distributed. So number next, that is step 3, that is conduct the one sample t-test. Then lastly, step 4, estimate the effect size using Cohendy test only, that is only if the test is significant. That is, if the test in step 3 here is significant, so we should proceed to estimate effect size. But if the test is not significant, so there's no point in estimating effect size, because there's no effect. Because if there's no effect, what size are we now trying to estimate? We are trying to estimate the size that is not there. So now let's go. So the non-hypothesis before us is that we want to test if the average weight of the mice differ from 25 grams. So the data set we are using, the data set called named mice, and it contains the weight of 10 mice. So these weights are different. So we want to check if the average weight, that's the mean of this weight, is significantly different from 25 grams. Okay, now let's import the data set. I've already set the working directory, so you can check. If you are ready to do that, you can do that. So I've set the working directory. I'm in the right folder. So now I want to import the data set. So using the function read.csv, then the name of the data, the name I use to save that file. So here I have mice. You can see this is the name I use to save. So and then I'm going to put .csv, see, to tell how that this is a CSV file. Then I'm assigning this data set to mice_df. So let me import the data set by running the line of code in line 15. So I run it. So data set I've imported. You can see mice here. That's showing me that I have 10 observations and 2 variables. So I may want to view the data set by I can run the code in line 17. That is view. The function I'm going to do is view. Then I view it. Then now you can see I have 10. We have minus 1, minus 2, minus 3 up to minus 10, and these are their respective weights. Now let me attach the data set for convenience. Now attach data set. I attach data set, yes. Then I want to load all the required packages. All the required packages. All the packages I'm going to use in this test. So I'm going to use site package, then EG_POP package, then outstatus package. All these 3 packages I'm going to use. If you are to install them, you can just come here to the package coordinates here, then you type the name of the package you want to install, then click install. Make sure you are connected to the internet and wait until you install. And after the installation, you can now load by writing this code library. Then the admin will be the name of that package. All these all these 3 packages at once. So I just align all them at once. Then I run. You can see I have the good response here. I've run all of them. Now I want to follow the step. I said step 1 says that estimate descriptive summaries of the variable. And the function I'm going to use, this describe. This function is in site package. Can be found as site package. Then I put describe, then that is, I'm not going to write mice underscore df dollar the name of the variable. I'm going to make reference to the variable ID because I've already attached the data set. Then this is the name of the variable. Weight, as you can see here. Then let me run the Studio statistics. Now you can see the statistics. I have variables. How many variables I have? I have one. Then number of observation, that is N. Then the main weight of the mice. So we have 20.14 gram. Then the standard deviation is 1.9. We have mean, we have 3 mean. We have the minimum weight. That is the mice that has the minimum weight as 17.5 gram. Then the one that has the highest weight as 23.4 gram. Then the range is it. We have the skewness, that's 0.52. 0.5, and we have the kurtosis, that is minus 1.08. Then I have the standard here 0.6. Okay. Now, the next thing is to check for the normality. That is because that assumption is very important. That assumption must be made before we can use one sample t-test. So now we are using visual inspection test, that is the graphical method. Let's check by plotting our ggplot. So this ggplot function is available in ggpubhal package. So then in the argument is going to be the name of the variable, that is weight. Then let me run that and wait for the plot. You can find all the data points, most of the data points. Okay, you can find that around the line, aside from the one that lies outrightly here. Okay, so here we can conclude that the variable is normally distributed. That is the assumption has been made. So let's also check format test. Let's use format test. We are going to get the same thing. So we are using Shapiro test. We use Shapiro test. You can see that the function Shapiro test. Then we put the weight inside. That's the argument. Let's see. You can see that the p-value here is 0.38 and is greater than 0.05. So here we cannot reject the known hypothesis of normal distribution. So therefore we conclude that the variable is normally distributed. That is, the assumption has been made. Now we can now proceed to conduct our one sample t-test. Now step 3 now. Conduct one sample t-test. To conduct one sample t-test. So we mind you, we want to the hypothesized mean is 25 gram, not 100. Sorry, 25 gram. We want to check whether the main weight of the mice is significantly different from 25 gram. So that we are testing. So, and we are going to use the function t_test. This function is available in our statistics package. So then the first argument in this function will be dataset. The name of dataset, that's data equal to mice df. You can see that is the name of dataset. That is the name we assign it to, mice_df. Then comma weight, that is the name of the variable. Then we are going to run it on 1, just 1. Okay, because we have only one variable. We don't have group. So then mu, we are going to have mu, that's mu, our hypothesized population mean, that is 25 gram. That is what we are trying to check whether the mean weight is different from. So we are going to put it there. So then we are going to run that. If we run this now, we are going to see our result. You can see the result here. So we are interested in the p-value here. You can see that the p-value of 0.00002 is even far less than 0.01, and let's use 0.05. Okay, so we can see that this test is significant. that is showing that the mean is different. That is the average mean of mice is significantly different from 25 gram. Significantly different from 25 gram. So having found a significant result, so we can now proceed to calculate our effect size. So this effect size, we are going to use the function coens underscore d. That function is available in our statics package. And then the argument, we are going to write the argument in this bracket. The argument I'm going to write, the first argument is going to be the data set. We have data is equal to mice underscore d. That is the name of our data set. Then we are going to have the variable we are running for 1. Then we have the hypothesized mean, that is 25. Then we run it. If we run it, we are going to see that. So we can see the effect size. So you know really what levels and sign here. So we have the effect magnitude. So you don't need to disturb yourself now. But when you are writing the effect size, you ignore the negative size. You ignore the negative sign. So just 2.5 is about the arrangement of is the sign that the population mean is less than the hypothesized mean. That is what you can see if you check up here. If you check here, you can see the mean here is 20.14, which is less than the hypothesized mean. So what we are trying to do here is see if you subtract this, you will see that this the mean here, the sample mean here is about 5 grams less than the hypothesized mean. Okay, so what we are trying to do is to see that whether that difference is actually significant statistically or not. That's what we are trying to do. So the negative here means that we have the hypothesized mean being greater than the sample mean. So when we are interpreting the effect size, so we ignore the sign. So we assume this is 2.56. Okay, so this magnitude is large. Okay, that is the effect size here is large. Here we come to the end of our one sample t-test. Thank you.